Hello everyone, I am Dr. Ravindra, Assistant Professor in the Department of Mechanical Engineering, NMAMIT, Nitte. So, I along with Dr. Grenell, we are trying to have online classes through the lecture videos so that you can understand better. So, today we will start with the first chapter, projection of points. Now, the point means it is the smallest object without any dimensions. Now, this projection of points deals with the four quadrants, first quadrant, second quadrant, third quadrant and fourth quadrant. Now, what is this quadrant means? You take two plane surfaces like this, one is called as the vertical plane and the other one is called as horizontal plane, and this is the intersection of VP and HP. So, this horizontal plane we call it as HP and the vertical plane we call it as VP, and we have the four quadrants. This is called as the first quadrant, this is called as second quadrant, and this is the third quadrant, and this is the fourth quadrant. Now, if you look from the front for you, this 3D quadrant system looks like two lines. This is one vertical line and one horizontal line. Now, these two lines are represented here. So, this is the horizontal line, we call it as HP, this is the vertical line, so which represents the VP. So, this is the 3D view and this is the two dimensional. Now, here the intersection of VP and HP, so there will be one more line you can see here. So, this is the line of intersection of vertical plane and horizontal plane. So, we call it as XY. So, this is the XY line. Now, when the point is located in these quadrants, the point may be in the first quadrant or maybe in the second, third or fourth quadrant, and the observer always is fixed in one position. For example, now this is the quadrant system, I am the observer. So, here this is the observer. So, we are not going to move the observer to different location, observer position is fixed and we are going to draw this quadrant system, first quadrant, second, third and fourth quadrant. Now, for the observer, how these points will look like? For example, if the point is here in the first quadrant and I am the observer, it looks like this. The point is so many millimeters above HP and so many millimeter in front of VP. Now, here if the point is in the first quadrant here, for the observer it is above HP and in front of VP. So, I will write here, if the point is in the first quadrant, so it will be above HP and in front of VP. Similarly, if the point is in the second quadrant here, I am here only, I am not going to move, that means the observer is here, but the point is in the second quadrant. Then how it looks? It is for the observer it is behind VP and above HP, or for me it is behind VP and it is above HP. So, second quadrant it is above HP only and behind VP. Now, if the point is in the third quadrant here, for the observer this is first, second and third quadrant here. For the observer you can see here it is point is here in the third quadrant, it looks like below HP and behind VP. Below HP and behind VP. If the point is in the fourth quadrant, now here this is the fourth quadrant, it is below HP and in front of VP. It is in front of VP and below HP. So, these four lines are very important to decide the point belongs to which quadrant. So, you have to remember it very carefully. As soon as you read any problem, you have to decide which quadrant that particular point belongs to. Is it first quadrant or second, third or fourth quadrant? Now, if a point is in the first quadrant, for example, if the point is here, this is in the first quadrant. Now, the image of this point on the vertical plane, you will get an image here like this. So, we call this as front view. Similarly, we will get one more image on the horizontal plane. So, we call it as top view. So, two images obtained on VP and HP. The image which is obtained on VP we call it as front view, and the image which is obtained on HP we call it as top view. Now, this top view and front view, we have to make the difference by naming. The views are named. Normally, any point, for example, this is a point, it will have a name. All the points will be named with capital letters A to Z. You can use any of this just for calling. If the name of the point is A, then its front view is named as, small letter A dash, A with a dash, and its top view, it is named as small letter A. Similarly, there will be one more image in the side plane or the profile plane. So, that is called as A double dash, A double dash. So, this is the profile view. Now, here the point is in the first quadrant. So, its front view is on VP, its top view will be on HP. Now, this is in the 3-dimensional. Now, we have to draw it in the drawing sheet or in the grid sheet, that is the 2-dimensional. So, how to convert this 3D into 2D? So, 3-dimensional images are there. So, front view you are going to get on the vertical plane and top view will be on the horizontal plane. So, front view is called as A dash and the top view is called as A. So, I cannot draw it on the grid sheet as it is. So, we have to convert this into 2-dimensional. For that, we have to keep the vertical plane vertical itself, just we have to rotate the horizontal plane only. You have to remember, we are going to rotate the horizontal plane by keeping the vertical plane constant. So, how we have to rotate? So, just you can see here in this direction, if this is the first quadrant, I am going to rotate the HP like this. Now, how it looks? So, if you rotate like this, the horizontal plane and vertical plane, this is the first quadrant, I am going to rotate the horizontal plane, it looks like a sheet. Then what is this line? So, this is line as X and Y. So, I can draw it on the sheet here. So, this is XY and the space above this, so we call it as vertical plane. The space behind this, below this, we call it as HP. So, this is the first quadrant. Now, if on the drawing sheet anywhere there is a XY line and above that it is written as VP, below that it is written as HP, then you can understand this is in the first quadrant. This is the first quadrant. Now, what about the second quadrant? If the point is in the second quadrant here, now I am the observer which is here. So, the point looks like above HP and behind VP. So, I have to rotate the HP in this direction. VP is constant. Now, for the second quadrant, only this portion we are considering. Forget about the remaining quadrants. Only you have to concentrate only on the second quadrant. This is VP this is HP. So, I will rotate like this, both xy line is here, this is VP and this is HP. So, I am going to rotate the HP like this. Then you can see here both VP and HP are merged together, it is above the line. So, for the second quadrant it will be VP and HP both are above the line. Now, coming to the third quadrant. Now, this is the third quadrant. The point is below HP and behind VP. You are the observer here. So, it looks like behind VP and below HP. So, I am going to rotate the HP in this direction like this. So, this is the one and this is the XY line and here. So, I am going to get exactly the opposite of the first quadrant. That means the HP will move up, VP will be down. So, this will be VP and this is HP. So, this is for third quadrant. So, when the point is in the fourth quadrant, so it is below HP and in front of VP. So, I am going to rotate the HP. So, just concentrate only on these two planes, that is fourth quadrant is here. So, I am going to rotate like this. So, forget about all three quadrants, only concentrate on the fourth quadrant. So, I am going to rotate the HP down like this. So, both HP and VP will be below the line. That means the fourth quadrant you have to represent like this, VP comma HP. So, whatever the drawing you are going to draw, front view or top view will be below the XY line. So, there is nothing above the line. Above the line nothing is there. So, this is the fourth quadrant. So, this is how we are going to draw the quadrants, first quadrant, second quadrant, third quadrant and fourth quadrant. Now, coming to the distances. Suppose there is a point in the first quadrant. We will take one example. A point A is 50 mm above HP. Point A is 50 mm above HP and 30 mm in front of VP. So, 50 mm above HP and 30 mm in front of VP. So, what is the distance from VP? It is 30 mm. So, from VP it is 30 mm. Then, how much above HP? It is 50 mm. So, from HP it is 50 mm, from VP it is 30 mm. Now, where is the front view? So, this is the front view. Then what is this distance from XY line? So, front view will be on VP. So, I will call this as A dash because already I told the front view is named as A dash. So, this point is A dash, the front view. Now, what is this distance? The view which is represented on VP. So, I can see this distance. So, this distance is with respect to the HP. How much above HP? How much above HP? That will be visible in VP. That means this distance is, in this example it is 50 mm. This example it is 50 mm. Then there will be one more image on this HP. One more image on the HP. So, that is called as top view. I will call it as A. Then what is this distance? This distance is how much in front of VP? In front of VP is 30 mm. So, this distance from here, from XY line, this distance will be 30 mm. Now, this is 30 mm and this is 50 mm. After drawing this, just if you rotate it here, it looks like this. There will be XY line, this is your drawing sheet now. There will be XY line, above the XY line there is a point which is 50 mm above the XY line. So, I call it as A dash, which is the front view, and there is one more point which is called as a top view. So, we call it as A, and this distance is 30 mm. Now, I will show you how we are going to draw it on the sheet. So, draw a xy line and draw the quadrants for the first quadrant, that is here it is VP and this is HP. This is for the first quadrant. Then leave some space and draw a light line, vertical line, very light line. So, on this line you have to measure a distance of 50 mm from this particular xy line from you. Here you measure a distance of 50 mm and mark a point like this. And similarly, on the same line you have to measure a distance of 30 mm below this line, 30 mm, and mark one more point. Then after this you have to give the dimensions, this 30 mm and 50 mm you have to mention it here. So, from here you draw a light line, here also you draw one more light line. By using the 2H pencil you have to draw all these lines. Only the XY line you have to draw it with the HP pencil. Remaining this vertical line and these lines you have to use only the 2H pencil. Then after that, from this particular line you leave a gap of minimum of 10 mm. You can leave 2 centimeter or 3 centimeter or any distance, but minimum should be 1 centimeter or 10 mm. If it is less than 10 mm, it is wrong. If it is more than 10 mm, nothing wrong. So, leave a gap of more than 1 centimeter and use the 2H pencil, drop a vertical line, once again it is a light line. Then draw the arrowhead like this. Then put the dimension, the 30 mm, you have to mark it like this. This is 30. Similarly, here this is 50 mm. So, draw a line, light line, and draw the arrowhead. Then dimension it 50 mm. Now, while dimensioning you have to take care the units are not written here, because at the end of the drawing sheet here it will be printed. All the dimensions will be in millimeter. If it is not printed, you have to write. All the dimensions are in millimeter. So, do not write the units along with any of the numbers. It will be understood that if you write 30, it is 30 mm, or if this is 50 means it is 50 millimeter. Now, here just I have written only the front view and top view. Now, coming to the profile view. Now, there is a profile plane like this. This is the profile plane. So, VP, HP and profile plane. Now, in this profile plane, the distance from the profile plane also will be given in the problem. If it is not given, you can take it conveniently. This distance, for example, this particular example, the point A is 50 mm above HP, 30 mm in front of VP and 100 mm from profile plane. Maybe the right profile plane or left profile plane. There are two profile planes, one is here, one more will be coming on the other side. So, it will be mentioned particularly in the problem from LPP, that means left profile plane, or from RPP, right profile plane. If it is not specified, it is free to you. You can take either LPP or RPP. So, accordingly you have to solve it. The plane which is to the right of you, so that is called as right profile plane. The profile plane which is to the left of you, we call it as LPP, left profile plane. Now, the image of this is the point, it is 50 mm above HP and 30 mm in front of VP, and there will be one more image here on the profile plane. I can see one more image. So, this is called as a profile view. The name of this is A double dash. Name of this is A double dash. Now, there will be a line intersecting with VP and profile plane. The line of intersection of vertical plane and profile plane. So, this corner. So, this line is called as X1 Y1 line. So, this line is called as X1 Y1. So, this line will represent the plane of separation of VP and profile plane. Now, once again, to convert this 3D into 2D, how I rotated the VP and HP, similarly the profile plane is also rotated. We have to rotate it like this. So, the plane becomes like this. This is HP, this is VP. To the side of VP there will be profile plane. Always this is very important, because whenever we are going to draw on the second quadrant or the fourth quadrant, you will be confused. Always the profile plane will be adjacent to VP. So, your profile plane cannot come here, because this is HP now. We are talking about the first quadrant. First quadrant means below the XY line is HP, above the XY line is VP. So, while drawing here, always the profile plane will be adjacent to VP. That means there will be XY line and there will be one more X1, Y1 line, and we call this portion as VP, and below that HP, and adjacent to VP there will be a profile plane. If the profile plane is to the left of you, so we call it as LPP. If it is to the right of you, so we call it as RPP. Now, in this example, I will show you how to get the profile view. So, after this, you have to measure the distance from this particular point. That is, already I had drawn a light line connecting the front view, that is A dash, and the top view, that is A. From here you have to measure the distance, whatever the distance from the profile view. If it is not given, conveniently you can select any distance and you can draw a vertical line. So, once again this is by using a HP pencil, dark pencil. So, I will call it as X1, Y1, X1, Y1. So, this is VP, this particular ground, so call it as VP. Now, this space, it is HP. So, adjacent to VP, that means this space we call it as profile plane. Since it is to the right of you, so we call it as RPP, right profile plane. Then there is a procedure to draw the profile view. So, it is only a procedure. For any quadrant you have to follow the same procedure. It may be first quadrant, second or third or fourth quadrant, you have to follow this procedure. But for drawing the front view and top view, you should know the system what I told. Front view means, so above HP and in front of VP, this is first quadrant. Second quadrant means behind VP, above HP. Third quadrant below HP, behind VP. Fourth quadrant in front of VP and below HP. So, this is to decide the quadrant. Once you draw this front view and top view, then drawing the profile view is the same procedure. Now, adjacent to HP, so this is the HP, so this is VP, so this is the profile plane. There is a blank space, so this is the blank space, no name is given to you. Now, here you have to draw a 45-degree line, a light line. A light line is drawn here, which is inclined at an angle of 45 degree. No need of giving the number, just you have to draw a 45-degree line. That is the first step. Then after that, go to the top view. You have to remember this, not to the front view. Go to the top view. What is that top view? The A, not A dash. A is the top view. So, go to the top view, project it towards the 45-degree line. Just extend a 2H line, extend a 2H line up to 45 degree. Now, when it intersects with the 45 degree line, stop here, then divert towards the front view. If the front view is here, you have to move it up. For example, if it is in the fourth quadrant, then the front view may be here, then no need of moving up, you have to move it towards the front view, so move it down. So, always remember, start from top view, project it towards the 45 degree line, then divert the line towards the front view. So, that is very important. So, divert it towards the front view. Now, my front view is above here. So, I have to move it up. Then come to the front view and project it towards that line like this. So, this is also a light line. All these construction works are very, very light. So, intersection of these two lines will represent the point. So, that is called as A double dash. This is the A double dash, that is the profile view. So, this is how we are going to solve the problems. So, your projection of point means this is the solution. It may be first quadrant, second quadrant, third or fourth quadrant, you are going to get a solution like this. If this is the first quadrant, so it will be like this, VP and HP. If it is second quadrant, then HP and VP both will be above the line, nothing is below. If it is third quadrant, it will be exactly the mirror image of this, HP will be above, VP will be below. Accordingly, this naming will change, all the procedure will change. If it is fourth quadrant, then both VP and HP will be below the line. So, this is the procedure to solve the problems. Now, while solving this, because this is a very simple drawing, here the weightages will be given for the dimensions also, how the dimension lines you are going to draw. Now, the arrowheads, what we are going to draw here. So, it is also very important. So, draw a light line, then at the end of this the arrowhead like this. Now, for this there will be a ratio length to width. If the length of the head is 3 units, then its width should be 1 unit. That means width should be less, length should be more. Do not use the scale and go on measuring 1 mm and 3 mm. Just by your practice, you have to take care that the width is less and length is more. This is the practice you have to do while drawing the arrowheads. Then for dimensioning also, you can see here dimensioning. So, a dimension line will be drawn here like this, and at the end of that there will be 2 projection lines. So, in between this we are going to place the dimension. There are 2 methods. One is called as unidirectional system and other one is called as aligned system. In aligned system, we are going to place the numbers above the line. In unidirectional system, we are going to split the line and we are going to write the number at the middle by splitting it. 50 or 100, whatever the number you are going to write like this. This is one system, this is the other system. Now, if the dimension is in the vertical, this is for the horizontal. For the vertical lines, I can draw a vertical line like this. This is the vertical line, and in this system, I have to write the 50 like this, and unidirectional system, we have to split the line from the middle and I have to write the number vertical only. I have to write the number vertical. You can see here both these two numbers are vertical. So, that is why it is called as unidirectional, only one direction. Aligned system means it is aligned like this. So, this is the procedure you have to remember. So, in aligned system, if this is the sheet, I can read it either from the bottom or I can read it from this side. These are the two directions from where I am going to read the numbers. That means the 50 or maybe the 50 like this. So, I can read it from this. So, now if you look from here, it is 50 which is above the line, 50 is above the line, and if you read it from here, this is also above the line. and in unidirectional system it is only one direction. All the numbers are like this. It may be vertical also, but still the number is aligned with only one direction. That is why it is called unidirectional. So, these are the two systems. You can adopt any one, but do not mix it together. In any one of the drawing, either you can use this or you can use this, which is convenient to you. So, but do not use both system in one dimension with aligned system, one with the unidirectional. Do not use like that. You can select either this system or this system, but follow it uniformly in a particular problem, and concentrate about the arrowheads. That is most important. Most of you are very lazy enough and drawing the arrowhead like this. So, this is wrong. So, this included angle should be very less. So, arrowhead, the width should be less, length should be more, like this. So, you can use three types of arrowheads are there. Initially, we are going to use it this type, that is open arrowhead. After little practice, you can draw this closed, or there is one more. If you are very good in the drawing, then you can use this closed and filled, but this should be very neatly drawn, then only it will increase the beauty of your drawing, otherwise it will spoil the beauty. So, that is why the filled arrowhead should be used only if you are very skilled. Otherwise, now you stick on the open or the closed, because the ratio is very important. This is 1, this should be 3, only by practice. So, you have to practice many times drawing of this arrow heads. Now, for this particular chapter, you have to remember this drawing, the 4 quadrants: horizontal plane, vertical plane, first quadrant, second, third and fourth quadrant, and the observer. Then the point is, first quadrant means above HP, in front of VP, second quadrant means behind VP, above HP, third quadrant below HP, behind VP, fourth quadrant in front of VP and below HP. So, this you have to remember. Then converting this into 2-dimensional. That means, if the first quadrant means there will be XY line, this is XY line, and VP is above, HP is below. This is first quadrant. If it is in the second quadrant, then this is the XY line, both HP and VP will be above the line. This is VP, comma, HP. This is second quadrant. So, you have to proceed with this procedure. And third quadrant, you have to draw XY line, and this will be HP, below the line it will be VP. Fourth quadrant, it is X and Y and VP, comma, HP. Now, these lines, that is XY line and VP, HP, all those should be SP pencil. It is the dark line. So, this is about the projection of point, the theory part. If you understand this much, then the remaining part is only solving the problems. You have to solve one problem from each quadrant. So, remaining you can solve yourself. There will be a question bank provided, in that all the questions will be there. You can solve that. So, first we will take one simple example from the first quadrant. I will write here, point A is 40 mm above HP and 30 mm in front of VP, and 50 mm from RPP, right profile plane. Draw the projections. Draw the projection. So, this is the problem. Now, if you read this, the point A, what is the name of the point? A. It is 40 mm above HP and 30 mm in front of VP. So, forget about the remaining dimension, it is not so important, only to draw the profile view this is required. But above HP and in front of VP, that means it is the first quadrant. So, as soon as you understand that the point is in the first quadrant, so you have to prepare this quadrant system X, then Y. So, first quadrant means it is VP and HP. Then after that you draw a line x1 y1. So, see here, is it RPP means it is to the right like this. So, this is x1 y1. So, all these lines are dark line and this VP HP also should be visible. X is capital X, Y is also capital, this is also capital, all the letters are capital only. Then this is for the first quadrant, that is for this first problem. Now, from profile plane it is 50 mm. So, this is the profile plane intersection line, that is x1 y1. From here you have to measure a distance of 50 mm and drop a light line, very light line you have to drop it. What is this distance? This is 50 mm. You can mention it anywhere, either you can mention it here or here, anywhere on this line you have to give this dimension 50 mm. The point is 40 mm above HP. From this XY line, this is 40 mm above HP, that means it is available in VP. So, from here, from this point you measure a distance of 40 mm and mark this point. So, this is the front view. So, we call it as A dash. Then on the same line you measure a distance from here, the VP distance, what is that? 30 mm. So, from here you measure this distance, this is 30 mm and call it as A and give the dimensions. From here you drop a light line and one vertical dimension line and arrowheads. After that the dimension 40 mm and this is 30 mm. And 40 mm. Now, you have to draw the profile view. So, what is the procedure? Adjacent to HP, there will be a space where you have to draw the 45 degree line. So, above this, this is the RPP, right profile plane. Now, come to the top view and project it towards the 45 degree line, move it up, then from the front view draw a light line. So, intersection of this, it is the profile view A double dash. So, this is the solution what you have to draw it on the drawing sheet or grid sheet, or in the computer also we are going to draw it using the SolidEdge software. So, this is the solution for this particular problem. A point which is 40 mm above HP, 30 mm in front of VP and 50 mm from right profile plane. Above HP and in front of VP means first quadrant. So, that is why I have prepared this first quadrant VP and HP. Then all the dimensions with respect to HP, what is that dimension? 40 mm. 40 mm above HP or below HP, whatever the dimension with respect to HP, you have to represent it on VP. So, you can see here 40 above HP. So, that should be on VP. Similarly, all the dimensions with respect to VP, it may be the angle or it may be the length. With respect to VP means it is visible or which is represented on HP. So, 30 mm in front of VP, that means it is on HP. Then this is about the profile view. So, this is a problem on first quadrant. Now, we will take a problem from second quadrant and we will solve it how it will differ from the first quadrant. Now, I will give the name as point B. Second problem, a point B is 40 mm above HP and 30 mm behind VP. Remaining I will keep it as same. Point B is 40 mm above HP and 30 mm behind VP and 50 mm from RPP. Draw its projection. Now, it is above HP and behind VP. Above HP, behind VP. That means it is in the second quadrant. So, that is the first step. After this, you have to prepare the quadrant system for the second quadrant. Draw a XY line, then HP and VP both are above the line because we have rotated the HP. So, VP is already here, HP also will go above the line. So, that is how the quadrant system for the second quadrant is, everything is above the XY line. Then it is RPP, that means to the right. So, I will draw XY one line here. So, this is X1, Y1 and to the adjacent to HP. So, adjacent to VP is here, this is RPP. Adjacent to HP means the same space, do not come below because everything is above the XY line. Now, from profile plane it is 50 mm. So, from profile plane you measure a distance of 50 mm and draw a light line. So, this distance is 50 mm. Then on this line you have to mark the point. What is that? 40 mm above HP. So, from here you measure a distance of 40 mm. So, this distance is 40 mm. Then 30 mm behind VP. On the same line you measure a distance of 30 mm and mark this point and put the dimension. Mm. Now, you have to give the names for this. One is B and other one is B dash. Then how to differentiate which is B and which is B dash? That is important. If the naming is interchanged, then whatever the drawing you are drawn till now, it is of waste. You will not get any weightage for this. It is the wrong. Now, 40 mm above HP and 30 mm in behind VP. So, above HP means it will be in VP. So, all the dimension with respect to HP is available in VP. Then already I told the front view is in VP. So, that is the second point. Then the name of the front view is dash, A dash or B dash, like that. That means the HP dimensions are available in VP. So, in VP the front view is available. The name of the front view is dash. Now, here the HP dimensions 40 mm, 40 mm above HP, that means this is in VP. So, this becomes B dash and this is 30 mm behind VP, that means this 30 mm is with respect to HP, it is available in HP, that is why this is the top view, this is the front view. Now, the profile view. To draw the profile view adjacent to HP, this is HP, this is adjacent to HP itself. So, here itself you have to draw the 45 degree line. So, some of the students will draw 45 degree line here or here, because this is the second quadrant, you should not draw anything below the line. Draw a 45 degree line. Now, you should be very careful, you have to follow the procedure, otherwise you will get a different solution. What is the procedure? After drawing this, you have to go to the top view, project it and move towards the front view, and from the front view you have to draw a line and you are going to get B double dash. So, always remember, in any of the quadrant, the front view and profile view should be in a single line. If front view is here, your profile view cannot come here. It is wrong. You have to cross verify where is the mistake. Always in any of the chapters, the front view and profile view should be in the same line or in the same plane. Why it is? For example, this is the point you are observing from the front. So, this is the front view. Similarly, I am observing from this direction and you are going to get one more view. So, this is called as a profile view. What is the level of these two? They are in the same level. Now, if you are moving it like this, so this is the profile and this is the front. That means both will be in the same line. Always, irrespective of the quadrant, you have to ensure that the front view and profile views are in the same line. Now, this is the solution for the second quadrant, a problem with the second quadrant with RPP. Now, I will solve it instead of RPP if it is given as LPP, left profile plane. If they give, what changes you have to do? Now, the procedure will change, the drawing procedure will change. The quadrant is second only, but they mentioned that it is left profile plane, to the left of you. That means profile plane should come to the left and the remaining should be the right. So, you have to draw the x1, y1 here, and this will be the profile and the HP and VP will be here. So, you have to write the VP and HP here, VP comma HP, and this is LPP. You can write it here or you can write it here also. Remaining procedure will remain same. From the profile plane, a distance of 50 mm and specify that distance like this, and above HP 40 mm. So, this is B dash 40 mm and 30 mm from VP. So, from here 30 mm. So, this is B and dimension that like this. Then profile view, draw a 45 degree line. From the top view we project and project it up, and you are going to get the B double dash. So, this is the difference, RPP and LPP. Same problem in the previous one what I solved, it is right profile plane, now it is left profile plane. So, same procedure will be there, but it will be the mirror image. So, this is about the second quadrant.